Hi everyone, welcome to my channel Kodmad TV. My name is Pavithra Kodmad and you're watching a guide to Google Chrome's Performance Profiler. In this video, I'll show you how to use the Performance tab in the browser DevTools. We'll learn how to record a profile, how to navigate the timeline, how to use the network section, and how to inspect the main thread of the runtime. We will do so by profiling and inspecting two websites, the DevJokes and codesandbox. This is the Google Chrome browser. I'm using the Canary version, which is my preference. You can use any modern version of the browser and this tutorial will be valid. You can open up the Google Chrome's DevTool by right clicking and clicking on inspect. Alternatively, you can also use command option I to open up the DevTools. DevTools has a number of tabs. For this tutorial, we'll be using the Performance tab. In here, you can see that there are already a number of options for you to play around with. This tab allows you to record the runtime of your application and then provides you with the profile or graphical interactive representation of what code was run during that particular recording. As per the instructions that it shows here, you can click on the record button that is present here to start a new recording. What it means is you can click on the record button and then make a search for Chrome DevTools Profiler. And you can stop the recording. Now you can see that it shows you the profile of a new recording of your Google search. That's how you record an interaction on your web page and look at its profile. To clear a recording, you can click on the clear button and the tab will come to its initial state. You can also click the reload button to record the first page load of this page. So if I click on the reload button, you can see that the profiling has started and the page has reloaded, and the profiling stops automatically when it thinks that it has enough information. Let's clear this. You can also upload and save particular profiles. This can be useful for sharing profiles between developers. Other options that I use include the ability to change the network conditions in which the recording will happen or the CPU conditions. So you can use this to simulate a fast 3G, a slow 3G, offline mode, or any other custom profile. The CPU throttling option allows you to simulate conditions where the hardware used by your users might be at. So a phone may have a slower CPU and you can simulate it using these options. In my experience, I have found that changing network and CPU conditions results in different kinds of profiles which can be interesting to investigate. The first website that we'll be profiling today is a small one that I created a couple of weeks back. It uses a Nuxt.js that in turn uses Vue.js. So let's open the Google Chrome DevTools and head over to the Performance tab. If you use the dev version of your application, you will get a much more rich profile than using a production version of your application. This is basically because JavaScript is obfuscated and minified in production versions. Dev versions will have source maps which allow you to see exactly what's going on in your application. So let's profile the first load of the DevJokes application. So the profiling has stopped. So here we have a profile of the DevJokes application. To look at the profile in more detail, I sometimes undock the profile and prefer to look at it on my monitor. Let's walk through the different sections of this recorded profile. The first section here is the timeline of the recording. It tries to give you a summary of what happened during the recording. For those who enable the screenshot option, you will see a nice set of screenshots of your app state at different points of the timeline. This can help you quickly see which parts of your app are stuck in a certain frame for a long time. Or it can highlight janky intermediate state that may not be immediately visible on load. If you enable the memory section, it shows you the heap memory usage for your profile. I haven't used this section much. Let me know in the comments if this section has helped you diagnose any memory leaks or some such problem. In this timeline, the yellow corresponds to JavaScript activity, the purple to style calculations, the blue to HTML parsing, and the green corresponds to repainting of the browser window. Everything below the timeline shows detailed information on different aspects of this profile. You can select different windows on the timeline by using click and drag of your mouse or by adjusting these bookends around the window. All of the details below will zoom in on the part of the timeline that you have selected. Another thing to note is that scrolling kind of zooms in and out of the content below the timeline. This can be slightly confusing to newcomers who are using this tool for the first time. When you are zoomed in into a section of the timeline, you can use click and drag at this bottom part to shift the window that you are looking at or to effectively scroll the timeline. Below the timeline, you will see effectively two sections. One is this set of tabs that show a different aspect of the profile, and the other is this more details kind of section that shows you more details on the things that you have selected in the upper part of the profile. I don't use much of the frames, interactions, raster and these other tabs below here, so I won't be talking much about them in this video. Among the most useful parts of the profile is the network section. This contains the same details as the network tab in the Chrome Developer Tools, but the info is much more clearer because it is set against the timeline. The network tab shows the beginning and the end of each network request made by your application through the browser. Here you can see that the first request was an HTML request. Once that got done, the next were requests for JavaScript assets. Then some CSS assets were requested for. You can also see API calls, image requests and so on in the network section. These little lines around each request are called whiskers, and they kind of represent latency, which may be because the thread is busy or the network is slow or some such reason. Hovering over each request shows us information like the priority of the request, and the time taken to for the request to get us some results. Clicking on the request itself shows us some of the same and more information on the summary panel. So you can see it's a CSS URL, you can see the duration, the request method, priority, type, data and so on. The next most important tab that I look at during profiling is the main thread of the application. The main thread is responsible for showing user-facing content. So if the users of my application are seeing a performance issue, then this will be the place to look for it. So this shows all the work that the main thread has done over the course of the timeline. The data structure that this section uses is called a flame chart. The nature of the flame chart is to taper down as it reaches the bottom of the section. These bars at the bottom will show us the innermost function or task that was executed. When you hover or click on each of these bricks in the chart, you can examine more details on what work was done here. The summary here says that the evaluate script took a total time of 900 milliseconds to run and a self time of 847 milliseconds. The self time here means the amount of time the function spent on itself. The difference between these two is the amount of time spent in the execution of its children. So here it shows that this evaluate script of app.js took about 900 milliseconds. 847 milliseconds is the self time. This is the time taken by this task alone, and the difference between these is the time taken to execute the children functions. I found that lining up this main section with the network section gives me a good insight on the order of event execution. For example, here the network request for CSS was made, the CSS was downloaded. As soon as it downloaded, you can see that the browser recalculated its time. This little red cap here indicates that this was a long task. But my experience has been that many JavaScript executions end up being long tasks even for small applications. These lines here represent different milestones in the loading of your application. This here is where the DOM content loaded event is fired. This is where the first paint is supposed to have occurred, and these lines here represent first contentful paint or first meaningful paint or the largest contentful paint as per the browser. And this here is where the onload event happens. So this gives you a good idea of the difference between the DOM content loaded event and the onload event. If you have your screenshot mode on, you'll see that these lines are also represented here and roughly correspond to the points in your app where these events occurred. If you're running the development version of your application, your framework can show you more execution details in this timings tab. Here I'm using Vue.js. So it shows me what Vue functions were executed. First of all, this tells me that all of my app code started getting executed at this point. You can see that this mirrors my app code structure. So this is the root. Then there is a transition. Then it uses the layout. The default view is rendered. Then in the default view, you can see that init was called, the vsheet was called, vsheet has vapp has vcontent. Then there is a button which is rendered, it's initialized here, rendered here, and various aspects of the button are rendered here, like the next link is initialized, rendered, and patched. Okay, buttons, another next link. This is where the page renders. This is the first card that I show in the middle of the page. This is this card. I think these these were the renderings of these buttons, the home, submit, and the about buttons. And this is the rendering of the actual page. This is the card in between. Now when the image loads here, when the image loads, it re-renders the image patch here. Nice. So that gives you a pretty good idea of what's going on in your application. Since this was a very small app, it was pretty easy to profile it and see all the details. You think it's a matter of getting familiar with your application. So the next time you make some changes to the app, if you see a difference in how the profile looks, then you can dig into it further, see which methods are causing the delay, and then go back to your code and fix those methods. Now I want to profile the first load time of codesandbox client app. I chose this because it is an older code base, it's open source, it's written in React.js, and it's popular among a lot of developers. I forked the project on GitHub, cloned it on my local machine. The package.json says that yarn start should work, so I'll try that. This is the recording I have for an instance of codesandbox. I had a Google page open, and then onto that same page I pasted a URL of sandbox and recorded this profile. I've saved this profile on my GitHub and I have linked it in the description. If you want to follow along with the video, you can download the profile from GitHub and upload it here and see the same things that I am seeing on the screen. The first step I take is to look at the screenshots panel. The screenshots give you a good idea about the visual flow of the page. Here you can see that the app loads with a blank screen and then populates it with the skeleton. So we can kind of conclude that maybe this app doesn't employ server-side rendering. The app almost has heroic amounts of loading states. You can see that the app kind of comes alive at every step until the editor loads up and the code receives syntax highlighting to suggest that the page is ready. I don't particularly find that the timeline has any useful information other than acting as a good anchor when I navigate across my profile. Next, I open up the network tab. Here we can see the point at which the app was requested. And then you can see a waterfall of other network requests that were made. Next I whip up the main thread and then align it with the network tab here. And start my analysis. I find myself alternating between the network, the main thread, and looking for details in the summary and filtering using these other tabs when I'm making a performance analysis. We can see here that the browser receives some amount of HTML at the end of this point, and it then starts to parse it. It may encounter some JavaScript here, maybe it was in the script tag within the HTML, and processes those two in the same task. You can also see that some CSS, JS, fonts, etc. were requested. It's pretty nice how everything lines up. For example, once the CSS is loaded, you can see that the browser started a recalculation of styles task. And once the app.js is completely loaded, the task to evaluate and compile that script starts here. So if you make an optimization to reduce or split the bundles in your JavaScript, you can see that these brick lengths may change. That is, if it's a smaller bundle or if it's a bundle that's called at a different time, you can make that out in this network tab. However, I'd like to emphasize that the timings that are shown here, for example 523 milliseconds, are not absolute. They may vary in different conditions depending on how busy your CPU is, how many tabs are open in your browser, what Chrome extensions you may have, and what kind of internet you may have, and so on. Only look for relative changes while comparing profiles. So once the app.js loads up here, the task to evaluate it starts here. Because we used a development build, we can clearly see which files and which methods were executed in this flame chart. You can also check out what files were imported and so on. This section is where I look for opportunities to make optimizations in my code. Since you're on a dev build, you have the accompanying timings flame charts as well, which can help you determine what's being rendered and show you framework specific details. Another interesting thing is you can also see the exact points at which API calls were made in your you can also determine the exact points at which API calls were made. For example, here index.json seems like an important piece of information because the app completes loading only after that info is there, and you can see that it's being called halfway through the execution of this task. We can of course spend several hours exploring this profile and understanding the app deeper. But I think this much explanation is enough for this particular video, as it's getting a bit long. As a conclusion to this exercise, I had 3 observations that I wanted to make about this profile. So all of the CSS that is being fetched here, does it have an impact on the performance? They seem to be highest in priority. That would be the first thing that I would note and dig deeper into. My second suggestion would be to probably make the API call for this index.json a little earlier, but that may or may not be feasible in the current app structure. My last piece of observation was to kind of maybe asynchronously load some parts of app.js. My eye first landed on this DevTools component inside this editor, and I was wondering if it could be lazy loaded and save us some part of JavaScript execution. In this video, we opened up Chrome DevTools and learned how to use the Performance tab. We learned how to create a performance profile recording and how to make sense of it. Finally, I want to note that every profile of every app will be different and very tied to the domain of the app. So the more you are familiar with the profile and code of the app, the better performance improvements you can make in it. That's it for this video. Thanks for watching and see you next time.